Now let's take a look at how to use Excel to calculate our geometric means in order to figure out average percentage changes. We're going to stick with return on investments. What we're looking at in this Excel file are two different mutual funds. I actually got this data from an investment advisor because we have a chunk of, we're looking to invest funds from the homeless shelter into a mutual fund so that some of our extra cash can be used to earn some income. So we were offered by an investment advisor the American Balance Fund on the grounds that it tracks the market generally pretty well, but it's a little bit less risky. And we're, of course, very conservative investors, meaning we don't want to take on high risk. So we have the return rates on the American Balance Fund, the ROIs, going back to 1975. Recall that this is just a percentage change in the value from one year to the next. So this is from 1974 to 75, 75 to 76, and so on. We have the same data for the S&P 500. That is one of a fund that is considered a broad market index, meaning it kind of represents the market, so to speak, right? So we can make a comparison. And as you can see, we have these data, some are positive, some are negative, going all the way to 2020. So we would like to average these. Now recall for percentage changes for the geometric mean, what we have to do is we have to add 1 to the percentages, and then we use the geometric mean, and then we pull the 1 off. And that order of operations is important. So when we add 1, the result, we'll call it the growth factor. So for the growth factor for the American Balance Fund, we just take 1 plus B2. And I'm going to pull that down. All the way to 2018. And I don't want them to be percents. So I'm going to, up here in the middle of this ribbon, I'm going to select the down arrow and just make them general numbers. And so we've got a little bit more decimal accuracy there when I converted them back to decimals. And now we just do the same thing for the S&P 500. Of course, the nice thing is if I just pull this across, Excel knows to switch from column B to column C, and now I'll just drag this down. All right, so we have all of our growth factors, the 1 plus XIs for all of these, for both. Right? And we have a lot of XIs, right? So now we want to find the geometric mean of the two columns. So that's going to give us our average growth factor. So we're going to use the same trick to type in the range of cells. So for column D, we're going from D2 all the way down to D47. So here's how we do this. As always, start with an equal sign. And now we type GEO, and you can see the suggestions coming up, MEAN. Right? Just like har mean for harmonic mean, geo mean is the geometric mean. And now we're going to average from D2 to D47. There's that trick where you type in the first colon last, and we hit enter. And we've got it, right? It's about 1.1362. And now if I drag this across, it's going to replace the C's, the D's with the E's. So now let's finally get the average return. So we're going to take D48 and subtract 1. And I pre-formatted this to be a percentage, and I'll drag it over. So the American Balance Fund, since 1975, so that's in the last 45 years, has earned an average return of 13.62%, whereas the S&P 500 has averaged about 11.58%. Part of the reason why, if you go through some of these data, is that the S&P 500 has far more negative returns than the American Balance Fund. So therefore, the American Balance Fund is going to end up having a slightly higher average return, and it has less risk. So what should you take away? So from this section, we talked about, well, we were about, first of all, in the last section, the mean that we used for the center of our distribution was the arithmetic mean. Add everything up, divide by how many you have. We used the harmonic mean to average rates. Recall that we accomplished that in Excel using the harmean function. And finally, the geometric mean is used to average percentage changes, but we have to add 1 to each of those percentage changes, then find the geometric mean, and then subtract 1. And the geometric mean is found on Excel using the geomean function. In the next section, we're going to step out into the second parameter we use to describe data distributions. How spread out are the data?